This video is about Karnaugh Map, which is also known as K-Map, which is used for minimizing different Boolean functions. The main purpose of minimizing any Boolean function is to represent the given function with minimum number of logic gates. So K-Map is simply pictorial representation of a given truth table, for which we are implementing the given function, and it is made up of different squares, and each square will be representing minterm values. The main thing is how many number of squares or how many boxes are required to representing each term. It is only 2 power n, where n is the number of variables. So if we are having 3 variables, so for 3 variables 2 power 3, total number of required boxes will be 8. If we are having 4 variables, so it will be 16 here. So why we are taking base 2, as we already know that we are dealing with binary number system. So for any binary number system, we can only have two numbers to represent it, that is 0 and 1. So that's why the base is 2 for binary number system. That's why we are taking here two values, and n is representing number of variables. So if we are having any two terms, suppose we are having two variables a and b, the maximum possible combinations that can have, it can be a dash b, it can be ab dash, it can be ab, and the last it can be a dash b dash. So for a given two variable 2 power 2, it will be equals to 4. If we are having three variables, suppose the variables are a, b and c, the number of terms can be 2 power 3. The total terms can be 8 here. So based on these number of terms, K-map is designed, and whenever we are representing in this form, it is your min term. I am not discussing min term or max term here. That is already covered before K-map. So coming to the K-map part, if we are representing any given two variable function or any two variable minterm values using K-map, so we can easily see that whenever we are having four boxes, 1, 2, 3 and 4. So for given four boxes, since the variables are 2, so here we can see that one variable is x, second variable is y. So y can be having only two values, either it will be 0 or it will be 1. Similarly, x can be having value, either it will be 0 or it will be 1. So coming to the first box, so this square, we can easily see that this value is represented as 0. Again, this y value is also 0. So we can represent in min-term form x0 as x dash and y0 value as y dash value. Similarly, in this case, we can see x is having 0 value and y is having 1 value. So we are representing in min-term form as x dash y. In this case, both the values are 1, 1 for these boxes. This value is 1, this value is 1. So for both the cases, we are having 1, 1. So the value is xy. Now, how the minterm will be assigned? Since it is representing 0, 0, so it is represented as m0. It is representing x0, y1, so it will be m1. It is representing 1, 0, so it will be m2. And it is representing 1, 1, so it is m3. So what we are doing, we are just representing m0 with 0, 0. M1 is 0, 1. You already note that this is your minterm representation. So when M2 1, 0 and M3 as 1, 1. So this is M0, M1, M2 and M3. So suppose take one single example for two variable K-map. If we are having any given function, so this is representing, if the function is f x comma y, it is representing that there are two variables in this given function. So if number of variables are 2, we have to design K-map with 2 power 2 equals to 4 number of squares. So here we are having 4 different boxes. The min term is given as, this summation sign is showing you min term value. It is represented as 1, 2, 3, means for this given min term values, the output will be high. So just what we are doing, since we are not having any value corresponding to M0, this 1 is represented here, M1, 2 is here, M2, and this is 3. Now the next part is how to minimize given minterm in K-map. So for that, we have to start with grouping the adjacent squares. So first we can choose number of squares as 2, it can be 4, it can be 8, or it can be 16. It can always be in the form of 2 power n again. So here we can see that 1 and 1, they are making adjacent pairs again. This 1 and 1, they are making adjacent pair again. So we can easily find out the common terms in these grouping part. So here we can see that, see carefully this part, when we are grouping this 1 and 1. So for both the value m1 and m3, these values are high. For this case, for x1 values are different. For this case, x1 is, or x value is 0. For this case, x value is 1. But y is common for this term. So we can say that using y, we can represent these two minterm. Similarly, when we are taking this group, again the same thing is here. The values are 0 and 1. This value is again 0 and 1. So m2, m3, they cannot be represented by y because y is 0 for this case, 1 is for this case, but x is common. So we can say that it is represented by term x. So at the end, when we are making it final, the function can be represented as sum of minterm x plus y. So if we are solving this, again the final answer will be x plus y. So what we are doing, we are just minimizing the given function with the help of K-map. If we are talking about 3 variable K-map, so when number of variables are 3, 2 power 3, it will be acquiring total number of 8 squares or 8 boxes. The minterm value will be, it will be from m0 to m7. So for 3 variables, suppose we are having here the values as x, y and z. So x can be either 0 or 1. YZ value can be 0, 0, 0, 1, 1, 1 and 1, 0. See, for all the K-maps, whenever we are having 2, 3 variables or more variables, we generally follow gray code for representing these values. So the advantage of gray code is, you can see here, only one bit is changing at a time. It is 0, 0, it is 0, 1. Only one bit is changing again. It is 0, 1, it is 1, 1. Only one bit is changing again. Again it is 1, 1, it is 1, 0. Only one bit is changing again. So whenever we are doing for K-map, the value should be this only. It should be 0, 0, 0, 1, 1, 1 and 1, 0. Now how to define different so showing you minterm value m0. In this case, x value is 0, so that's why it is x dash. Y value is 0, it is y dash. Z value is 1, it is z. It is representing m1. Remember that it is minterm representation in which we are representing 0 with complement part and 1 with non-complement version. Again, at this case, x value is 0 for this row. For yz, the values are 1, 1, so we can represent it. So this is representing 0, 1, 1. So 0, it is 0, it is 1, 1. So 0, 1, 1 is representing your m3. Again, this term is being represented as this x dash is 0, it is 1, 0. So it is representing your m2 term, 0, 1, 0, it is m2. Now for this row, since the value of x is 1, for all the cases you will be getting here x non-complemented, so it is 1. The top portion is 0, 0, so it will be 0, 0. 1, 0, 0 is representing your m4. Again it is 1, 0, 1, so it is representing your m5. In this case you can see that it is 1, 1, 1. Top sides are 1, 1 and this side is 1. It is representing m7 and the last one is 1, 1 and 0. It is representing m6. So now we are having all the minterm being represented here for 3 variables. It will be starting from m0 and it will be going to m7 maximum. So suppose we are given with any function f that is having 3 variables x, y and z. So the function is given as summation of 2, 3, 4, 5. Again sum is showing you minterm value. So we are discussing about minterms part. So here just see carefully that it is 2, m2, m3, m4 and m5. So it is m2, it is m3, it is m4 and m5. Now we have to find the adjacent square pairs. So here one pair is here, one pair is here. See, in this case, for both m2 and m3, this value x value is 0. So here x value is taken as x dash. For this case, y is 1 and y is 1. So we can take directly y value. Since z value is 1 in this case, 0 in this case, so z value is not used because it is not common in both the term. So this is represented as x dash y. Again, for this term, we can see that this value is representing 1. So for both the cases, the x value will be 1. The y value is 0 here, y value is 0 here. So we can represent this 0 term with y dash. So the final solution for this will be x y dash. Now the final function can be represented as sum of different product forms. So f will be equals to x dash y plus x y dash. So although we have started with 4 different minterm values, but in the end we are getting 2 simplified terms. So that is the advantage of using K-map. So we can easily implement or we can easily minimize any given Boolean function so that it can be implemented very easily by logic gate. So if we want to implement this part, there is requirement of one OR gate. In this, there is requirement of AND gate, there is requirement of AND gate. So by using minimum number of logic gates, we can implement this portion easily. But when we are implementing this term into canonical form, in that case, there can be requirement of different number of OR gates, multiple inputs, and there can be requirement of different AND gate also. So for different example, we will discuss later.